Okay guys, so first thing we're going to be talking about today is graphing systems of equations. So this is our Unit 2 information. So with graphing systems of equations, the first thing we have to do is we have to graph each linear function. So remember guys, linear function solely means a straight line, so we're not going to have any curves or anything like that. Second thing you have to do when we're graphing systems of equations is find the intersection point. So when we find the intersection point, guys, that's usually our solution. But before we do any of that, I want to go over what form we have to be in to graph our systems of equations. So the form we have to be in, if y'all remember, is slope-intercept form. So guys, slope-intercept form is very basic in what we do. It's going to be simply y equals mx plus b. So the b is our y-intercept. What that's strictly going to mean, guys, is that whatever that term is that is in place of b is going to be the point that we start on the y-axis. Then we have our m. So our m is our slope, which if any of y'all remember is going to be rise over run. Slope and rise over run are equivalent to the exact same thing. So then we're going to, now that we have an understanding of what form we need to be in, we're going to go to example 1. So our first example is y equals 1/2 x plus 3. And then we have 2y plus 3x equals 14. So our first one is in y-intercept form, so we're just going to graph that one. So first we take our 3, and that's going to be up 3 on the y-axis. So we're going to go 1, 2, 3, and I'm going to put a blue dot there. Then, now I'm going to focus on my rise over run. So I've got 1 for a rise and 2 as a run. We want it to be positive, so I want my line to look like this. So I'm going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. So that gives me that half of the line. Now the other half, I need to go the other direction. So I need both of my rise over run to be negative so that it gives me a positive slope still. So I'll go down 1 and to the left because left is negative and so is down. And I'm going to do the same thing all the way across. And that's going to give me my first line. Now I'm going to switch to red so y'all can see me work with the next one. So our next equation is not in slope-intercept form, so we're going to have to switch it to that. So first thing I'm going to do is I'm going to try to get y by itself. So I'm going to move my 3x to the other side by subtracting on both sides. So I get 2y equals negative 3x plus 14. Well, it's still not by itself, so then I'm going to have to divide by 2 on both sides. So now I'm going to do y equals negative 3 over 2 x plus 7. So this is this equation. So now I'm going to start at 7, so 3, 4, 5, 6, 7, right there. Then I'm going to go down 3, and then to the right 2, because I need it to be negative. So I need it to be a negative and then a positive so it maintains the negative symbol. So if you notice, I've already got an intersection point there, but we're going to keep doing our lines. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So this gets me my second line. So as I said before, we have our solution. That's going to be an intersecting point right here. So right there's my intersecting point, which is going to be 1, 2, 1, 2, 3, 4. So that's going to be positive 2, 4 is my solution. But then I've got my extra line here. And if y'all remember, that talks about how we're going to classify our graph. So inconsistent means no solutions. When we have no solutions, that usually means we have parallel lines. So parallel lines never touch. So if based on just our graph that we have right now, is our graph inconsistent? No, because we already found a solution. So that means we're going to go with a consistent, which means it has solutions or just one solution. But there's 2 different ways you can classify consistent. You can have infinite solutions. That usually means that it's going to have the same line. And it's going to be considered dependent. Then if we have one solution like we do in our graph, that's called independent. So now that we have these terms, I would classify my graph as consistent and independent. Okay, so now we're going to move on to our second graph. So first, I'm going to scrape out this 4 because that wasn't supposed to be there anymore. And we're going off of our two equations. So our first one I'm going to do in blue, and it's y equals -4. Well, right there, we don't really have a slope. We don't have anything attached to an x. So that means I can actually just go to the y-intercept, 1, 2, 3, 4. I can draw my dot, and then I can go straight across. And that right there is y equals -4. Check. That one's super easy. Anytime you have just a number by your y, you get to draw a straight line. If it's an x, you'll just make a vertical line. So now we're going with my next one, which is -x minus 8. So first we're going to start with putting our y-intercept, which is -8. So we've got 4 already there, 5, 6, 7, and then 8's going to be down here. So that's the starting point. Now, I said before, when we have a positive slope, we need to have our line going this direction. A negative slope, we need to have it going this way. So we have a -1 as our slope. So that means we're going to go down 1 and to the right 1 so it stays negative. And then we can do the same thing. We can go up 1 to the left 1 because it's a positive movement and then a negative movement, which will keep our line going negative. And so there's our second line. Now, I can find my y-intercept. Well, first, let's make sure that's correct, which it's not. I didn't go off the right intercept there. So that's actually going to start me here. So going up 1 here, 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 here. So notice me just going off the wrong intercept put me in the wrong place. But that's okay because I caught it and I was able to fix it. So here's my intercept now. And that's going to be at -4, -4, -4. Which, since it has a solution, is going to be consistent and independent. Okay, so now I've got my next one. Both of these are not in the correct form, so I'm going to have to move some stuff around. So I'm going to split my line here, and I'm going to do my first one. 3x minus 2y equals 8. So I'm going to move my 3x, so I get -2y equals -3x plus 8 divided by -2. And then I get y equals 3.5x minus 4. Now I'm going to work on the other side. So I've got x minus 2y equals 4 minus my x on both sides. And I get -2y equals -x plus 4. And then I'm going to divide by -2 again on both sides. And I get y equals 1/2 x minus 2. So now I'm going to graph both of them. My first one I'm going to graph in red. So I'm going to go down 4 for my intercept. Then I'm going to go up 3 over 2. Up 3 over 2. Up 3 over 2 because that's my slope. Down 3 over 2. So there's my first line. Now I'm going to do my second line. So my first spot is my y-intercept right here. Then I go up 1 over 2. Up 1 over 2, up 1 over 2. Perfect. Now I've got my blue line. And if you already noticed, our intercept is right here, which is going to give me 2, -1, which again is a solution, so that's going to be consistent and independent. So now, guys, we're going to move on to our next ones. So a couple of these are going to be a little bit different, and I hope y'all are going to be able to catch them. So the first one, we're going to just go straight off of this. We already have our one in y-intercept, slope intercept form, so we're just going to do it. So we're going to do our 2 as our intercept, and we're going to go up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. There's my blue line. Check. So now I'm going to make this one make sense. So I'm just going to divide by 4. Divide by 4, divide by 4, divide by 4, which gives me y equals 1/2 x minus 3. Okay, so now I'm going to plot that one. So I got 1, 2, 3, up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, and down 1 over 2. Okay, so this one's a little bit different. I don't have any lines that intersect, which means, guys, I have no solution. which means this is inconsistent because they're parallel lines. Okay, so now we're going to move on to number 2. So number 2, again, I'm going to plot my first one because it's already set for me. 2, 3 is my y-intercept, and then up 1 over 4. 2, 3, 4. Up 1 over 4. Down 1 over 4. Down 1. So here's this big old line. And now I've got to do the same thing over here. So I've got to divide by 4. Divide by 4. Divide by 4. So I get y equals 1/4 x minus 3. If you notice on this one, guys, this equation is the same thing as this equation. So all that means is my lines are the exact same. There's nothing different. That means they have a million intersecting points all through here because they're all the same, which means our solutions are infinite. And that means that we have consistent and dependent. Okay, so now we're going to move on to number 3. As you can see, both are in slope-intercept form already. So we're just going to graph it. So 1, 2, 3, 4, 5, that's my y-intercept. And I go up 1 over 2. Up 1 over 2. Down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. And I make my graph. Perfect. Okay, so then I'm going to go down 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. This one's a little different. This is a whole number. But our rise over run is still going to work the same. If y'all remember with a fraction, or even a whole number, if you have a 2, if you put a 1 under, it's the same thing. So that's how we're going to focus on rise over run. So we're just going to rise 2, 1, 2, and then we're going to go to the left 1 because we want that facing the other direction. 1, 2, over 1, 1, 2, over 1, 1, 2, over 1, 1, 2, over 1, and 1, 2, over 1, 1, 2, over 1. So that line right here, that's going to be our slope for our second equation. So we have an intersecting point, 2, 3, 4, 5, 6, negative 6, 2, which, because we have one intersecting point, is going to be consistent and independent. Okay, so we have 3 more problems. So both of these over here, we're going to have to switch into slope-intercept form. So we have 6x minus y equals negative 3. So I'm going to minus my 6x on both sides and get negative y equals negative 6x minus 3. So I need to get that negative away from my y. So I'm going to do negative 1 all the way across. And that's going to give me y equals negative minus negative times divided by negative is going to be 6x. And then negative and negative is going to give me positive 3. Then we've got our x plus y equals negative 4. Minus my x onto both sides, and I get y equals negative x minus 4. Now I can graph. So I'm going to graph my first one in blue. We're going to go up 3 points. That's my y-intercept. Then up 6. 1, 2, 3, 4, 5, 6 over 1. And you can do the same thing going down. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And there's my pretty first line. I'm going to switch to red to do my second one. So down 4, 2, 3, 4. And then it's going to be up 1 over 1, which gives us an instant point. But you can draw it out to make sure your line goes all the way through. And there's my pretty line. And my solution is going to be negative 1, down 2, 3, negative 3. And that means I'm going to have consistent and independent again. Okay, so for our next one, we're going to do the same thing. We're going to split our screen. And we're going to do our negative x plus 2y equals negative 4. So we're going to add 6x to both sides and get me 2y equals 6x minus 4. Then we're going to divide by 2. And that's going to give me y equals 3x minus 2. Now we're going to do the same thing over here. So negative 3x plus y equals 4. Plus 3x onto both sides. Y equals 3x plus 4. One quick thing, you notice our slope right here are the exact same. So that should give you a hint of what's going to happen next. But now we're going to plot them. So negative 2, and then up 3. 1, 2, 3 over 1. 2, 3 over 1. 1, 2, 3 over 1. down 3, over 1, and then we draw a pretty line. Then we're going to do our second one. So plus 4, 1, 2, 3, 4. Then up 3, over 1, down 3, over 1, down 3, over 1, down 3, over 1. And again, our lines never touch because our slopes are the same, meaning that our terms here are parallel, which means we have no solution. So that means it is inconsistent. Okay, so we have our last one. So we're going to split our screen again, and we're going to do x minus y equals negative 3, minus x onto both sides, negative y equals negative x minus 3, divide by negative so you can get that negative away from your y, and you get y equals x plus 3. Then we're going to do the same thing on this side. X plus y equals negative 5, minus x onto both sides, and you get y equals negative x minus 5. Now we plot. So I'm going to plot my first one, 1, 2, 3, then up 1 over 1, up 1 over 1 all the way across, and same thing going down, and draw. Then I'm going to do my next one, so negative 5, 1, 2, 3, 4, 5, and just the opposite because it's got a negative slope, so I'm going to be going up 1 over 1 to the other way. That's going to give me a straight line here, and my slope point is going to be right there, which is 1, 2, 4, negative 4, negative 1, which is consistent and independent. So guys, that is graphing systems of equations. You should have 9 problems on your homework. Hope this helps you get through it.